Today we're going to review the basics of solving equations. If you remember from 7th grade, we tried to keep in mind two big ideas when solving equations. One is that our goal is always to isolate or get the variable alone on one side of the equation. That's how we know it's solved, because you've got x equals something. I do want to remind you that just like when you were solving problems working backwards when you were younger, the way you undo something when you go backwards is you use the opposite operation to undo something. It's something to keep in mind. Again, a big idea. The other big idea, I know undo is not a very mathy word, but we're going to stick with that because I think you know what I mean. The other thing to remember is that if it says that something is equal to another, it's balanced. If I add something to one side, it's not balanced anymore. That means I have to add the same thing to the other side. In fact, no matter how complicated you get in your higher level mathematics, this will always be true. Whatever you do to one side, you have to do the other. Okay, the other. Let's take a look at what that looks like. Some basic ideas. I could say to you, x plus 3 equals 24. Easy peasy, because here's my variable. How do I get rid of plus 3? I subtract 3. I'm using the opposite operation. And the reason why that gets x alone is because what is positive 3 and negative 3? Or what is 3 minus 3? It's 0. And that's the same thing as having x alone. X is equal to 21. And here's the check. We know that something's a solution if, when we plug it in, it makes the equation true. So there we go. That's our check. It's a solution. What if, on the other hand, I have negative 12 is equal to, I don't know, negative 5 plus x? Well, now notice that x is on the other side of the equation. And what I need to do, how do I get rid of this negative 5? I want to turn negative 5 into 0 because 0 plus x is how we get x alone. The way I turn negative 5 into 0 is to add 5 because any number plus its opposite equals 0. When I add 5 here, I get negative 7 is equal to x. And once again, that's true because negative 12 equals negative 5 plus negative 7. Just one more quick example with subtraction. Come on. All right, just let's say that 15 is equal to x minus 8. Well, let's make it negative 15. Okay, so to get rid of minus 8, I add 8. And remember, all rules for signs apply, and you always bring your equal sign straight down. Negative 8 and positive 8 equals 0, so now I have x alone. Negative 15 plus 8. Unlike sign subtract, use the sign of the greater absolute value. There we go. Let's take a look now at what it looks like when there's multiplication involved. Again, let's begin fairly simply. If I know that 3x equals 15, once again, I'm going to say, here's my variable. I need to get it alone. What operation is happening with this variable? In algebra, when things are right next to each other, it means the operation is multiplication. To undo multiplication, we divide. So I'm going to divide by 3. I'm going to find out that x, and I have to do it to both sides, x equals 5. And as you already knew, 3 times 5 is 15. Of course you could solve these things by looking at them, but that's not what this is about. This is about using algebra. That gets just a little bit more confusing. If I tell you that 36 is equal to negative 6 times a number, okay, it's really not that different. We still are trying to get the variable alone. We can see that multiplication is happening with the variable. To undo multiplication, we clearly have to divide. But what about that negative? How do I turn negative 6 into a positive 1? Well, once again, any number divided by itself is what equals positive 1, and 1 times a number is the same as having the variable alone. So unlike in equations with addition and subtraction, when I'm using multiplication or division, I want to use the same sign because that makes it positive x, or a positive variable. Once again, if I do it to one side, I do it to the other, meaning that negative 6 is equal to 1x, or x. 1x is the same as x, so I can just erase that. It means the exact same thing. And once again, negative 6 times negative 6 does equal 36, positive 36, because same signs are positive. There we go. That often gets kids confused. What about if I have division? X divided by 4 is equal to, I don't know, 5. Okay. Of course, we know the fraction bar means division. Last year in 7th grade, I introduced you to the idea of a fraction destroyer. But basically, let's start with the looking at this equation. To get x alone, what operation is happening with it? Division. What undoes division? Multiplication. So one way of thinking about this is simply to multiply both sides by 4. This is, you can extend this fraction bar. This is like saying 4 divided by 1. Any number divided by itself is equal to 1. So I've got x alone, and that equals 20. We've found it helpful in algebra class to consider problems like this and think about them as using the fraction destroyer. So anytime you see a denominator, if you see that 8 is equal to, I don't know, 1/3 of a number, you can say, I have a denominator. The way I get rid of that using a fraction destroyer is to multiply the entire equation, that's why there are parentheses, by that denominator. That denominator that multiplying by 3 destroys this and leaves 1x. It also, if I do it to this side, I have to also do it to the other side. So I'm multiplying each side by 3, and that makes this 24. 28 is 1/3 of 24, so we know it's right. So when you see a denominator, you can use the fraction destroyer. It basically destroys the denominator and leaves what's left on top. Leaves what's left on top. But you have to then also remember that you are multiplying the other side. So what if it said 1/3 is equal to 8n? This is a little bit trickier. I do see a fraction, so I can use the fraction destroyer. In this case, what the fraction is destroying is this. So I'm going to have 1 is equal to 24n, and then I divide. This is similar to something that's in your sheet, but that's harder than anything that's going to be on the exam. Okay? Another thing that does come up have tonight is where it might say 2/3 of x is equal to, I don't know, 8. Okay, again, I see a denominator. If I multiply by that denominator, okay, it destroys the denominator. Okay, so that means that on this side I have 2x. I also have to multiply the other side, making that, I'm going to go back here and tell you what that was originally, making that 24. Now I have a second step, an equation with multiplication. What undoes multiplication? Division. So x is equal to 12. And that's our review lesson for today.